Hi guys, so in this project, we will be building a deep learning model that is to be trained on text dataset to predict the next sequence of words. We will then prepare our very own website that will be built using the Django framework and will be hosted on AWS. So let's get started. So the first thing I'm going to do is go through the contents of the project, right? I will give you an explanation or an introduction to the project, what we are building, how we're going to do that, what models we are going to use, what platforms we are going to use, right? Then we would dive into specifically which model we are going to build and train, then creating our Django project, that is the building of website, and lastly hosting that website on AWS. Now, in this project, we will be working on text dataset, which is a book written by Plato, the Republic. So our text dataset would be the words inside the Republic book, right? We pre-process the data into a more usable format and train our deep learning LSTM model. This model is based on neural network architecture and provides a very high performance on sequence-based dataset, right? As it has a feedback structure, helping the model remember the sequence of data input and changes that are happening layer by layer. Then we create a Django project, which becomes our base website, and that website will be hosted on AWS. Now building the LSTM model. So LSTM networks were actually specifically designed to overcome the long-term dependency problem faced by the RNNs due to the vanishing gradient problem. So the LSTMs have feedback connections, which makes them different to more traditional feed-forward neural networks, right? Now, this property also enables LSTMs to process entire sequence of data without treating each point in the sequence independently, but rather retaining the useful information about previous data from the previous layers in the sequence to help with the processing of new data or new data points, right? So creating the Django project. Now, when we say Django project, we actually mean a website, right? Using the Django framework. Now, Django is a free and open source web application framework written in Python, and it includes advanced functionality like authentication support, management and admin panels, contact forms, comment boxes, file upload systems, and more. So when we talk about contact forms and comment boxes, we basically mean the handling of front-end pages, serving the front-end pages, retrieving and sending the data from the backend to the front-end, right? So even that is to some extent handled by Django only. So in other words, if you were to create a website from scratch, you would need to develop these components by yourself. But using this framework, these components are already built in. You just need to configure them properly and maybe call some functions related to them to match your site, right? Now, this is the last part where we would be hosting our website on AWS, right? So we will be using the EC2 instance, that is the T2 micro, for hosting the website and understand how exactly the virtual servers are set up and the cloud system works. Right. With this completed, we will be able to access our website and run the model from anywhere across the internet. Now, uh, moving forward, we would first see how we're going to build and train our LSTM model. Hi, so this is the first part of the project where we will be building and training a neural net model. So first we will be understanding about the packages and the libraries we will be using, right? But even before moving forward with that, let's just have a look about the first code block that I have right here. Okay, so this is I'm importing a drive function from google.collab, right? As you can see. So why we are using why we are using this is because now your collaboratory is not connected to your drive, right? So if you want to access some of the files that you have in your drive from the collaboratory, you would need to run this command so that that folder or the directory is mounted onto your collaboratory here, right? So the function dot mount is actually going and seeing the path that it needs to go to, then find the folder there, which is the drive folder for me, and then mounting the drive folder or directory to my collaboratory so that I can access all the files and folders inside this drive directory. Now next you can see some of the string package or the library which is used for handling string data types, right? And the next you can see is the NLTK library. Now NLTK is a standard Python library that provides a set of diverse algorithms for NLP. It is one of the most used libraries for NLP and computational linguistics. Okay. Now the process of cleaning unstructured text data or analyzing the text data, converting the text data into different formats, I would be coming onto this later, right? All of that can be done through the classes and the functions that are built inside the NLTK library. So real world text data is, unstructured. It is not uh, uh, in a format that can be used directly uh, into the model, right? And also the data is inconsistent. The data might have a lot of noise. I mean, unwanted characters in it, right? So data processing becomes a very necessary step for which NLTK provides a lot of functions and classes, and some of those functions you would be seeing in action uh, when we move forward, right? So that is that. And the next, I would say the next important library yeah, the Keras library, right? Now this is, there's always some confusion about Keras and then importing Keras function through TensorFlow. Now if I'm writing from keras dot preprocessing dot text, right? If I'm writing import keras or if I'm writing from keras, then that means that I'm using the standalone library, that is the keras library. Now if I'm writing something like this here, tensorflow dot keras, so I'm now calling the keras library function that is embedded into the TensorFlow library, right? So there's a difference. You can't use some of this and some of this in the same code block or in the same function, because then it would create conflicts. So if you're using this for one purpose and you're using this for other purpose and both of these purposes are not interrelated, then you can work smoothly with both of these libraries. Okay, so Keras is a neural network library, as a lot of people know, if not. So Keras is an open source library, right, that provides a Python interface for artificial neural networks. Now Keras acts as an interface for the TensorFlow library also, which is, you can see that from here too, right? As I told you, Keras is embedded in TensorFlow too. So while TensorFlow is also an open source library, but a lot of tasks that are happening under the hood, and TensorFlow provides both high level and low level APIs for working with deep learning models and other models, while Keras only provides you with high level APIs. Okay, so this is the difference between them, and calling them like this, calling Keras like this or like this means they are coming from different libraries, and to some extent they might even have different functionalities even for the same function, right? So some of the packages that you see here are again all the packages required to handle string data type only, since our data type is a text data type, so not data type but data set. So we would need these libraries to filter out unwanted text or to get more information, to have a little analysis on the text data. We would need these libraries like the ray library or the string library, right? So okay, I missed out the NumPy library again. So NumPy, which stands for numerical Python, is a library consisting of multi-dimensional array objects and a collection of routines for processing those arrays. Now using NumPy, Mathematical and logical operations on arrays can be performed pretty easily and even in a very efficient manner, right? Then you see the random and pickle packages being used. Now, random basically means we're using a function that provides me some random numbers with the start and end index, right? So if you're using rand int, so that is giving me a list of random integers, okay? The next thing is pickle. Now, pickle is a package which helps us to save models, to save any kind of data that you want onto your disk, right? So uh, it has two major functions that are used, which is the dumps and the load. So we will be using them also, right? Uh, okay, just like I said before, the text data set that we are using is actually provided by Gutenberg, which has a lot of free and open source text data sets, which are actually textbooks or novels from famous authors only, right? So I did specify it that the book was The Republic by Plato. Again, you can even find the data set, this particular data set on the Gutenberg side also. And along with that, there are a lot of books that you can use as input for your models to train, and you can even see how the model is performing using each data set. Right, so I've just created a function that is loading my data set. Again, I have maybe named it republic.txt. So my txt file is open and then read through this function here that has the read function, right? I'm just opening the file first in read format, then I'm reading the file contents into my text text variable and returning the text. Next is my tokenizing function. Okay, so before moving forward, let me just yeah. So there are some methods we use to clean and then pre-process the data, okay, the text data. That is, we actually do feature engineering on the data to get uh, features which we can use as an input to my model and train my model on those features. So the first thing that we should go about and understand is the tokenization process, right? Once I give you a brief of what that is, we can move forward with understanding what is happening here, right? There's actually a lot of cleaning process before we go forward with tokenization. Now, the process of breaking down the text data into individual tokens, which can be words or sentences or even characters, is known as tokenization. So it is the foremost step in text analytics. And when text data is split into individual words, then it is known as word tokenization. And that is exactly what we are going to use. So it is implemented using word tokenized functions. And you can see that I have imported the word tokenized function here from my NLTK library. But before totally understanding what okay, so tokenization is clear, right? But why do we exactly need to tokenize that data, right? What's the need for that? Now, in machine learning and almost all deep learning architectures, we are not able to send or input string data types, right? So we need to somehow convert the string data into my number data, that would be float or int or double or whatever, right? So I need a number, right? We can't just simply input strings or characters into my model. So for that, the first process is tokenization, where I'm trying to get all my tokens that are words separately, so that later on I can perform a feature engineering task on it to convert those tokens or words into actual numbers or list of numbers, right? So which actually compels me to tell you about another process that is text vectorization. Sometimes people also call it as word embeddings, right? So basically, when we talk about tokenization, right? When we talk about tokenization, what it means is that if I have a sentence, I am going today, so it converts it into a list of tokens, that is I, then am, then going, and then today, right? So this is tokenization. The next thing that I was talking about, which was word embeddings or text vectorization, so that happens on this type of data set, right? I will talk about this in the later video, right? So see you in the next. Hi guys. So I would now start from where we left off last time. That was when we were learning, or more accurately, understanding what word vectors or word vectorization or word embeddings are. Right now, so when we say that with the help of word vectorization or using word embeddings, we can convert the text data into numerical ones. And I talked about how we would convert the word, let's say a simple word that is built on some characters, into a list of integers, right? Now let's say I have three tokens with me. I am happy. I have these three tokens as my data set. So what I did was, first I got my sentence, which was I am happy. Then I used uh, tokenization to get the tokens, which is I am and happy. Right. Once I am done with this, then we can move forward with word vectorization. So in my data set, I have only three words with me, right? My motive is to convert the text data into numerical ones. It doesn't matter if it's a list of numbers, if it is an array of numbers. I just want some numbers, right? So let's say that we have a three-dimensional space with us, right? I have my x-axis, y-axis, and z-axis. Right? So I have 3D space with me, and let's say one, one here, and one here. So going through each axis, if I go here, so at this point, I would reach 1 unit of distance from my start, that is 0, 0, 0. Now this is actually 0, 0. So this would actually be 1, 0, 0, right? Then this would be 0, 1, 0, and this would be 0, 0, 1, right? So I have my 3 points here, right? And if we move from here, one distance in the x direction, 1 unit distance in the x direction, I reach 1 point. One distance in the y direction, I reach 1 point. 1 unit distance in the z direction, I reach 1 point. So I have 3 points here, and I'm saying that this is going to represent I, this is going to represent am, and this is going to represent happy. My handwriting is not the best, but please bear with it, right? So I have got 3 points with me, and those three are now indicating each word from my data set. So when we talk about word vectorization or word embeddings, that basically means that I'm converting my data set into a list of, or into a vector of, yeah, saying vector would be a better uh, indication, right? So I'm saying that my I corresponds to a vector of 0, 1, 0. My am word represent is represented by 1, 0, and 0. And lastly, my happy is represented by 0, 0. So I can say that I have a vector, right? I have three vectors with me that determines or that represents three words in my data set. So this is basically how we are able to convert our text data into numerical data so that later on we can use that numerical part to feed into our model. So when but this was a very basic example, but let's say that I have actually four words with me, right? I am too happy, right? So there's also a word that is too. So how am I going to represent that in my 3D space here? So what I can say is that at 1 comma 1, right, at this point, which is 1 comma 1 comma 0, I will say that this is representing 2. So I've represented a new number from my existing works, okay, existing space, 3D space, right? We have considered that the space would be 3D. But let's say that we have not just four words, but 4,000 words, right? We have 4,000 words. How are we going to represent that in this 3D space? So what happens is that uh, rather than just being or just having elements in the ranges of 1 and 0 inside our 3D space, we will have something like 400, 256, comma 11. Right, this would be representing some word from my data set. There can be other that would be like 329 and 5,000. Right, this can also represent a number. But to just think about, can this vector really represent my uh, word vector data, which has 4,000 words only? I'm talking about 4,000 unique words right now, right? If my dataset has 4,000 unique words, then can this actually represent a word in my 3D space? And the answer is no. And the reason is pretty clear from here. Why would we need to go to a 5,000 level in the Z direction when we only have words uh, ranging from ranging from 0 to 4,000, right? So it doesn't make any sense to go that far to compute those higher numbers, right? We can just stay here. Anyways, even going for 4,000 words, we won't be even reaching this. But anyways, right? Just for understanding purposes. So this is what happens now in word vector when we talk about uh, dimensions, right? When we talk about dimensions. So if I have 20, 20, 20, 20, right? So one word is actually being represented by this vector. So this means that we have created a 4D space. We have created a 4D space, and in that 4D space, this vector represents one word from my dataset, from my list of unique words, let's say, right? If I have uh, 10, 20, going till 10, then I would say that the space I created is n-dimensional, and this vector represents one word from my data set, right? So, uh, so basically, all right. So basically, if I have a 3D space, why we call these vectors is because if I can just create one vector here, 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 one going here, going here, going here, and all of these points here actually represent vectors, right? Actually represent vectors which are actually mapped to unique words from my data set. That's why we call them as word vectors, or we call this process of building word vectors as word vectorization, right? So this is how it's being this is one way of creating numerical data or engineering numerical data from text data. Right, so this is what we are doing when we move forward and want to feed our text data into the model. Right, so that is that. And yeah, coming back to our functions that we created. So we have learned about tokenization, we have learned about word vectorization or creating word embeddings. So here in this function, which is named tokenize Twitter, again, basically this means just to tokenize and also clean the data set. So you can see there's different functions inbuilt in this particular function, which is clean HTML, replace URLs, remove emails. Then this function here is using the ray library, and the function is sub, which means that if I provide a expression here, it is going to compute and see if the sentence that I'm sending here has anything that is not fulfilling my expression. If so, then remove it with a space. So basically this means that anything that is not alphabets, lowercase and uppercase, remove that from my sentence and replace that with a empty string, right? Then we have the lower function to lower caps all the words that we have in our sentence, and then there's a miscellaneous function which basically removes new line characters, which removes single quotes, tabs, and anything. If you are written a URL, then it would remove that. Or if there is some words which are not defined, like WW, right? This is not any word, right? So I have removed those also. And lastly, removing Roman numbers from my dataset, because let me tell you, I didn't remove them before and it was creating major problems for me, right? So removing the Roman numbers from my dataset. So then this is a little cleaning process where what I'm doing is basically finding those sentences which don't have 5 words in it, right? Where the length of the string or the number of tokens that string has is less than 5. I'm removing those because they're too short, and LSTM already is renowned for its sequence understanding and remembrance. So we have removed these smaller sequence stuffs. Right. Okay, so before moving forward, you would need to uncomment them and download the WordNet at Monk, because these are some of the dataset and the library used by NLTK when you would be using the above functions that I have created. So here you can see that I have directed the path where my text data is present, and then I'm calling it. And then when we talk about length of the corpus, this basically means the length of the string. This has become a very long big string having all the data, and this is the length of the string. This is not the length of words, this is not the length of sentences. Okay, but we are creating sentences out of the string, that is using the dots, the split function, which splits on the basis of dot. So wherever in the string there's a dot, it would split into two new sentences. So you can see that there are a lot of sentences present, and you can see that there are a lot of Roman numbers present here with book, right? And a lot of slash n, that is new line characters, or maybe slash tab, or just a tab, or this here, this word www. So this was all removed. Now I've just made a pipeline for this and called both of these functions to clean up my data, and the cleanup data looks like this. Again, some of the things are not properly set up. You can even you can do a even better job than I did. Okay, moving forward, you can see here that this pro sentences actually is a list of sentences, and we have 6,309 sentences. That is a lot. And the major thing that I wanted to highlight is that I have only used 700, right? I have only used 700 sentences out of those 6,300. And the main reason is that when I was using even 2000 sentences, the model was taking like forever uh, to train. That's why I decreased the dataset amount so that my model would be trained a little faster. And the downside of it is something that I would again tell you about in when we are learning about the LSTM model. Right. So this is just cleaning the. This is just whatever was left here was also cleaned by this clean dog, right? And then here I am going to specify the sequence of tokens. So what we mean by sequence of token is that now I'm going to create my input data. I have my tokens with me, right? The words that are inside the sentences. What I'm doing is creating a list that has 51 sentences. Okay, sorry, not sentences, words, 51 words. And then what I'm going to do is the first 50 would be set as my input, and the 51st word would be my variable, dependent variable that I'm going to predict. Right, so this is how I'm making the x and y. So my x has a list of 50 50 words, and my y has one word, right? That is the predicted word. So that is what I'm doing here, as you can see. And yeah, I'm just again joining them again to make a sentence of 50 words, then the 51st word separately to have my x and y uh, input data. Then I've saved that data inside my republic sequence.txt file, and I've used a simple function for that. You can directly do that without building a function for it. I felt like I felt that yeah, making a function would be cool, so I just did that. Now again, I'm just loading the sequence data, right, and splitting the data on the base of new line. Here you can see that I've used a tokenizer again. So you can see that I have used the tokenizer. I have appended those words back into a sentence. This is a little redundant, but for clarity, for understanding what is exactly happening with your data, I did that. Okay, you can remove that or you can go forward with it. It's not an issue. Right, so we are tokenizing and calling the tokenizer function fit on text to understand how we would go about tokenizing. Then we have the text to sequence, which is basically transforming my text data into numerical ones, like the list of the vectors of numbers that are defining my token data. Right. So I have my vocabulary size also. That is basically meaning that the number of unique words that I have in my text. And lastly, I'm converting that into an array and building my y and x input data. Right. So this is the part where we are defining the model and we will be training the model. Now that would be done in the later video. Yes, so we would be starting off with defining, that is building our model, and then training our model to see how well it is working on the data set that we have just now input. Right. But before moving forward and really defining the model, let me just give you again a brief of LSTM networks. So I did cover some part of it in the introduction video, and I had highlighted why we were using LSTM, right? Because it has a feedback connection uh, feedback connection architecture that helps in LSTMs to understand the entire sequence of data, to remember the entire sequence of data, uh, which again helps in improving the accuracy, the predictive power of the model in for those datasets that have a lot of sequences in them, right? So that is why, as a result, LSTMs are particularly good at pre-processing and sorry, not pre-processing, but processing the sequence of data that would be maybe a text or a speech or general time series dataset. For the traditional neural network model, what happens is that when we feed the input into the first layer, and then the weighted bias with the weighted bias, we get some output from the first layer, which becomes the input for the next layer, right? And this is what happens in the network, where the first layer's output becomes the next layer's input, and then we go to the next layer, we have its output as the input to the next layer, till we reach the output layer, that is the last layer. But does last layer understand that the uh, what was the weight and what were the biases for the first layer? No, it doesn't. Right? It doesn't. So LSTM actually has a feedback network which helps in remembering, or which helps in understanding the right, which helps in understanding the which helps in understanding the right uh, which helps in understanding that the output layer also understand what was happening in the first layer, right? So that is how LSTM is working. Now we have just called out the sequential model wrapper actually, and then we are adding the embeddings, right? We are adding the first layer would be the embeddings layer, that is having the vocab size. Again, this is the list of unique words that we have, and then the 50 input layer, neurons, not layer, and the input length, right? Now, uh, why we have input vocab size here is because, as I told you, when we had 3D data vectors, we had three elements inside my vector. Now, what I have done is that I have created a word vector of length vocab size, which means that I have a vector where I have a vector where, let's say for word I have the vector 1, comma 0, 0, 0, 0 till we reach the vocab size. Then I have my next word, that is am. Then I have the word vector for it that as 0, comma 1, comma 0, 0, 0, 0 till vocab size. So by this way, I am able to create vectors, and the length of each vector would be the vocab size, right? Because each vector would have a value of 1 at a unique place to define a unique word in my vocabulary. Next, I have the LSTM model that I have used and given the input as 50. Again, same for the next LSTM model. Then we have the dense model. The dense model understanding what the input size was and using the activation function, which is softmax, which is again used for classification. Now we are doing classification here, right? How we are classifying? We're taking the input variable and seeing or classifying out of the unique words which word would be the uh, prediction, right? Basically what we're doing is that, let's say there's class A, class B, but rather than that we have word A, that is I, and word B, that is am. So I'm trying to predict if the next word should be I or am. So that is how the classification is working here. And then we've just compiled the model using the optimizer Adam and accuracy as the metric, right? And on fitting, we see that the accuracy reaches, yeah, only 27%, right? For 50 epochs. That is not less, but that is also not a large uh, cycle, right? So there are two reasons for that. One, as you can see, the model did increase its accuracy little by little, and you can see that the loss was also decreasing. So if I have gone for more cycles or more epochs, then I would have gotten better results. The second thing is that, as I told you, I took the data, a sub part of the data set, right? Only the first 700 sentences out of 6,000. So if you're using more data, your model would be built on more complex weights, and it would provide you with better accuracy, right? So you can try out by increasing your size of the data set and see if the accuracy increases or not, though there's not an option of if it is going to increase. The next thing is, what I've done is saved my model, right? Because I'm going to use that model again. But I've also saved my tokenizer object because it has been fit on the dataset, and it understands if I have some new data, how I'm going to transform that new data or text data into the vectors, right? Sorry, that is tokenizing. So text data into tokenized data. Okay, yeah. So this function I've just created to predict if I'm to just see if my model is working fine or not, and if I predict what would the output be, right? So it takes the value model again. I'm just going to pass this model here that I have saved here, then the tokenizer which I have saved here, se sequence length, that is the length I have used to define my input variable, which was again 50, then seed text, the actual text on which we are going to work upon to see what the next sequence of words would be, right? We have this as our input data, then we would use this to predict the next sequence of words. And lastly, how many number of words do you want? You want 12 words to be predicted after the seed text, or 20, like so. So what I'm doing is I'm predicting each and so what is happening is, in this cycle I predict one word, I append that and reset the in text, and then predict the next word, append that into the existing in text, then build and again send here to predict the next word, and I am doing this till I have completed the number of words I wanted to predict. Right, so that is what has been happening here. This thing here is a new function. You might have seen that in the above code also. So this is basically a padding function. What happens is that, let's say that I have created a word vector, but uh, it doesn't have as many the length of the word vector that I've created is not uh, as long as I require. So what I'm doing is I'm padding that. So let's say I wanted the length to be 6, but I'm only getting 5 here. So it would append a 0 at the end to make the length 6. But let's say that I have a word vector of length 7, but I only need 6. So it would truncate that. Means it would push it back or remove elements to let it come back to the length of 6. Lastly, I'm just predicting, and the word that is predicted is again uh, converted out and then inputted out with the outward, that is then appended into the result, and lastly the result is sent, right? Because even here only word by words are going inside the list, so you have tokens inside the list, not the actual sentence. So you have to join your words and create a sentence out of it so that we can return the text only. As you can see, I've just okay, yeah, so what I've done is I've just created I just got a line that is 50 tokens long, right? Because we have converted, or we have the sequence as a 50, we have the sequence as a 50 length vector. Then just load the model, load the tokenizer, send all of that data into my generate sec function, and as you can see here, so this was what I gave as input in the seed text, and this here you can see is the prediction, right? So after ages, which few great writers have ever been able to anticipate for themselves, they do not perceive the want of connection in their own writings or the gaps in their system, blah 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 blah. And lastly, you get the result that is best of the republic is not to be the embodiment. See, there's not, it is giving not 2 times. That is because it has predicted not should come 2 times. Again, the model is not the best model, but you can see that the next sequence of words are pretty much given out instantaneously by the trained model and the function we have created, right? You can even uncomment this, right, and see what is happening here. But note that I have the input data as not a string of 50 tokens or 50 words, but a string of, I think, 16 17 words, right? So if you input this, it is going to give you an error because your input data when you were training your model was a sentence of 50 words or 50 tokens that was then again uh, converted into vectors. So you would need a 50 long word string to be the input. You can just change that in the above code and create it to be a 10 or a 15 one, right? But with this, we have completed the first part, that was building and training the model. And the next part, we would be moving forward and understanding how we are going to work with the Django framework. Hi guys, so this is the second part of the project where we're going to develop a website using the Django framework. Right. So now Django is actually a free and open source web application written in Python. Right, as I gave you a brief of that in the introduction part. Now, together with all the functionality that Django gives, you can create your applications or website from an existing source code rather than creating and coding from scratch. So this is how websites, even simple ones, are designed by a single person, can still include advanced functionalities like authentication support, admin panels, uh, support for front end, files upload supports, and more. So in other words, if we were creating a website from scratch, you need to handle the front end part, you will need to handle the back end part, you will need to handle if they both are working properly or not, are in synchronization or not. You might be using other softwares like MySQL or Postgres for storing your data. Then you would also need to see if your website is working properly with your database or not. Is it able to query data or not? Right. But Django has a model template views architectural system which keeps all of that in mind and helps you in the requirement of front end and database management for a developer, right? So this is how even one person can build websites using Django and work simultaneously on database management queries, on front end, on showing data, on retrieving data, and handling things in the back end. So moving forward, let's first see how to instantiate the Django project. Right. So I've written down some steps that you can follow, but that some of the steps are only for the situation or only for the time when you are actually creating your Django project. So since you would be using this code base only, you don't have to run all the commands, but some of the specific commands that I'm going to tell you. Right. So in steps, you can see that in the steps file, the first thing is to create a virtual environment. Now you can see I've already created one. You can see that from here. But let's say if you're using an IDE like PyCharm, so there you just have to go to files. You just have to click on settings, and then a pop-up opens up where you can go to the project interpreter inside your projects, right? You can click on project interpreter, and then you can just click on this settings button here to add an a new virtual environment for this code base. Right, so you can see that you can create a new environment or you can use an existing one also. So once you create a new environment, it would load. Then once, or if you're on other IDs, you might have to activate your environment from the command line, right? Then what you have to do is you have to okay, so what you have to do next is, if you were to use the existing code base, the codes that I'm going to give you, then the next thing would be to actually okay. Okay, so there's one command that you have to run, which is pip install -r requirements.txt. Right, so if you are actually using the code base, then all you need to do is just install the packages and dependencies that this code requires to run. And then the next thing you would have to do is go inside your my site directory here, right? So my project directory is this. Inside that, I have my site directory here. So I'm basically inside here, right? I have all these files with me. So just type in the command python manage.py migrate. Now this command is specific to Django, and what does this do is that once you run this command, all the tables that that needs to be created by Django or that were defined by you inside Django, all of them will be instantiated and created in the database that you are using, right? So that is why you need to run this command migrate. It also helps in changing the let's say structure of the database. If you have changed something in that, you need to run the migrate command so that all those changes are reflected in your databases also, right? So this command is important. And then lastly, you need to run the python manage.py run server command. So this starts a local server on your machine, and then you can access and see how the website is functioning, right? Now, if you were to build a Django project from scratch, what would you do? So the first thing is again create a virtual environment. The next thing would be to install Django, any version that you want to, yeah, right, you want to use. Then what you need to do is run a command that is django-admin start project and then the name of the project. Like I gave my site as the name, you can give any name, right? Then cd means just go inside the project, right, from the command line, and then run a command that is python manage.py start app, then the name of the app. Now, what is project and what is app? I'm going to specify that in a little while. But before that, this is what you would need to do to create an app also. Then you would need to set up things inside your settings.py file, which I'm going to show you in a minute. And then rest of the commands are same for them. Right. So this my site project and this polls project was already created, so you don't have to run those commands, the start app and the project app, right? Even the Django version app, you don't have to, that would be specified in the requirements.txt. So going to the settings.py file, now you have to configure your Django project so that it works according to your wishes, right? Because Django does provide you with a base project where you can append things to build in functionalities that you want. But again, you have to configure the Django project so that it works accordingly. And to configure that, you need to make changes or bring on changes, other changes inside the settings.py file, at least for this project, right? So the first thing is to have a secret key. Your secret key is something which can be used to access your Django project and can be a person, an outside person. If he has the key, he can make a lot of changes in your project. Then the next thing is to set up the allowed host. That is again to tell that Django can talk or connect with which machines. So the access for that is specified here. Then you have your installed apps, which as you can see has admin, authentication, sessions, messages. So these are pre-built apps that Django provides you so that you can use its functionalities rather than writing code from scratch. But if you want something that is not provided by Django, you can create your own apps, right? As you can see here, I have specified the apps. So in a project, you will see files like these settings.py file, WSGI file, and in apps, you will see files like these. So this is where you implement your backend, connect your front end, work with your models. That is again databases, right? And this is just to configure your project as a whole. Next is the middleware. Now Django also handles middlewares for you. You don't have to code anything specifically here. Then we have the templates. Now templates are basically HTML and CSS files, those files which are served when you hit a URL, right? So those are called templates by uh, Django jargon. Next is the databases. If you want to use the inbuilt databases, that is SQLite 3, then you can just let it stay as it is. If you have some other third-party, okay, obviously third-party database like MySQL or Postgres, you can set up that here by uh, creating more keys like host, username, passwords, ports, etc. This is to create cache, how to store cache, how to retrieve cache. So that is again also handled by Django. You just have to specify how exactly is it to be handled. Okay, the rest of this is not that important right now, so you don't have to go and understand that in detail. But if you want to, you can just go to the Django project documents, and yeah, from the docs you can get a pretty clear picture about the some of the things that I have left out right now. Okay, so as this has also been, I would say, checked out, right? The settings.py is a file that is used for configurations, for handling of how the project is going to work. Then the next thing is to dive into the app and see how we are going to bring in functionalities that are required to be inside the website that we are building, right? So that is going to be covered up in the next video. Hi guys, so this is the second part of the Django framework and building the website, right, using Django framework. And in the last video, I missed something out, which was the .env package, right? So this package is used by um, it can be used by anybody who wants to keep his credentials, secret keys, sensitive information in a separate place and not inside their code base, right? So inside the .env package, we have the load.env function, which I will tell you later about why we are calling this function. But as you can see here, inside my site directory, where all the configuration files are present, I have the .env file. So if I click on this, you can see that I have my Django key, DNS address, IP address, all of that inside here, right? So what I'm doing is that I'm creating a .env file, right? And I'm saving all my sensitive information here. Then I'm calling the loadenv function to call and provide me with all the values from here. So we call them as keys, and all the values for these keys are called here, right? As you can see, I'm using the os.environment get function that is basically calling out the value for a particular key that we input here, right? So you can see that I'm calling the Django key so that the value it holds inside the .env function is saved here inside the secret key. Now let's say that there is no key of this name inside my .env function, then it would insert this inside the secret key, right? So now you might be thinking that let's say that somebody was able to access our code base, so he would also be able to access the .env file. Then he can get all the sensitive information also, right? But the thing is that once you run this .env file, all these keys and their values actually get stored inside the system variable. So once you run the code, you can delete this .env file, and even then, with the help of load.env, you can still call out the values for these particular keys from your system variables, right? So all of that value is then stored in your system variables, and the load.env function calls those values from those variables to here. So that is how you have all your sensitive information inside your system variables only, and then you can call them out so that nobody is able to access that sensitive information, even if they get a hold of your code base, right? Now, in the second part, what I wanted to emphasize on was the model views, a template architectural system that Django provides you, which handles the database management, which handles the front end and the back end, right? So I would be showing you the views.py file, right? This is actually inside the polls app, right? So I told you, if we want additional functionalities to be connected or to be built on your website or to be used on your website, you would need to specifically build those, and to that you would need to create an app, and inside that app you can build on those functionalities. Now, as you can see, I have a function here, right? It is taking a request parameter. So, views have functions or classes defined, right? So in those functions, you write your code to handle anything that is part of the backend, right? Meaning that if you want to uh, query some data from the database, you would do that here inside the function. If you want to uh, if you want to append something, if you want to bring out results from your data, you would do that here, right? So in the views, all the functions that we create have a specific return type, meaning that you would always have to return a render function which renders your front end, right? So each function takes in data and maybe manipulates the data, then sends back the data to the front end. But how it understands which front end or which page exactly we need to send the data to, that is done through the render. Right. So with the help of render, we again pass the first parameter as request. Right. You can see that this is actually defining the method. Then we have the index.html page, which means that at this page we have to send the data, and the data that we have to send is sent in a form of dictionary, which we also call context. Now there are two types of functions that I have built. One is specific to Django where we send in the request. So Django understands that this function is a function that handles the backend part and also is responsible to render a particular page. And when we say page, we also call them as templates in Django jargon, right? So this is how views templates system is working. But if you go, yeah, if you scroll a little down, you can see that I've also created a function predicting that is not taking a request parameter, right? So as you can see, it is not taking a request parameter, and here what is happening is that this function is not associated with any front end page, right? This is only to manipulate data and give back the results. And as you can see here, I've actually used the generate sequence function to predict the words, right? And lastly, I'm returning the generated text. So what is happening here is that first, when I run my code, views is run, and then the handler function is run, right? And then we see that if the method for request is post, then we ask the front end to give me the input. So we take that input here, right? Then we send that input to the predicting function where it goes into the model. The model predicts those words and gives us the generated text that is again stored in response. Then we send the response, that is our manipulated data, back to the front end using the context dictionary here. But as you can see, I have only defined these functions here and only called the predicting function here. But I haven't called handler function anywhere. So how do we call those functions, right? So this is happening with the help of URLs. Now, as you can see, there's a urls.py file also here, right? So what is happening here is that once you run your code and your server is running, be it locally or be it on the virtual server, what happens is that when you go to the URLs, right, like you type www.google.com. So if you go to a specific URL, then the handler function will be called. And to uh, process with that, we create URL patterns where we say that, or where we specify that on which path or on which URL which function is to be run, right? So as you can see here, on my home slash path, that is like the local host slash home slash, so that would be my URL, and I would show you in a minute. Then at that part or at that URL, you are requested to run the handler function. And once we go on that path and the handler function is run, the backend understands that, yeah, now I have to see if I have any input or not. If I have, I have to send that to my predicting function to get the results. And once I get the results, I have to just send back those results to my page, right? So this is how it is hand working. But again, this is just the templates and views part. So how does models come into it, and what exactly are models? So as I told you, models were, even here you can see that there's a model.py file present. So in models, this is pretty empty, but in models what we do is that we create tables here, right? We create tables here that specifies how exactly the tables and with what constraints those tables will be built inside your databases. So then what we do is that in the views part, we call those tables and query some stuff to get the data from the databases. So this is how the template views and model architectural system works. And in the index.html, that is our front end page. This is just basic CSS stuff, right? Then you can see here that I've created a form here, which has a post method and action. Action is basically where you want to redirect after the thing has been completed and submitted, right? Sorry. So here you can see that I'm taking the input. I'm taking the input here, and I've also given an example. If you don't want to type 50 words, you can just copy paste it and see what the results are, right? And I've also given a note as to you not making any mistakes while inputting the data, right? And I can see that there's something, yeah, yeah, right. So again, this sentence should be of 50 words, right? And I'm assuming that you are putting only string data types, because right here you can see that I haven't used any of the pre-processing functions that we had designed and also used in the first part when we were building the model, right? So take note of that also. And if you want, you can include those so that even if somebody enters words like hashtag, at the rate, www, or some URLs, so it would be, filtered out. The last thing that I want to talk about is the cache system. Now notice that each and every time your predicting function is called, it would load your, yeah, it would load your model here again and again, right? So this is going to make your site a little slower. And but here you can see that we haven't done the same thing for tokenizer. So for tokenizer, I just created a separate script where I'm creating a cache system, so that what happens is that once I create my cache, the tokenizer is saved inside my cache and is loaded inside my memory, so you don't have to reload it again and again, and you just have to load the model once, I mean the website once, and it would stay in the memory and you can directly call and use it again and again. And the reason why I haven't done this for the deep learning model is because the .h5 files are uh, a file type which is not uh, which the which Django is not able to pickle into, right? So we can't pickle or we can't extract .h5 files as a pickle file. And what cache system does is that it saves the file in a pickle format and then opens the file in the pickle format in the memory only. So you have to save your file as a pickle file, but H5 files do not get saved as pickle files. So that is why you need to load the models again and again. But the alternative of this is that you can create a sessions inside Django, and in those sessions you can just load the model once. Until the session is online, the model would be again staying in the memory rather than getting reloaded again and again. So you can even see and judge for yourself if creating sessions and loading your model in sessions would be a better option, right? So this is how the Django framework helps us in building websites that are pretty easy and pretty easy to use and to manage also, right? The last thing would be to actually run the server on local machine, and you can see for yourself how the website is working. Now for that you have to run the command python manage.py run server. Okay, so once you run this command, then it takes a little time to load the system to start the process of running the server locally. Then it provides you with the URL that you can see here. So when I talk about localhost or localhost URL, I'm talking about this specific URL right here. Okay, and even here you can see that the the port that Django uses by default is the 8000 port. And why I'm highlighting this here is because later we would be needing to specify the ports inside my AWS services also. Now, if I go to my home URL, right? If I go to my home URL, as you can see here, now it has loaded my page. So when I entered the home URL, the urls.py understood that I have to run the handler function, and then the handler function understood that I have to return the HTML page. As when we say return the HTML page, I mean render the HTML page. Okay, so the HTML page is rendered now. So either type in 50 words, right, or you can just copy paste this. I just written this here so that it becomes a little easier to test your model. Then you can just click on submit, and then it just loads the model, predicts the next sequence of words, and it would give you the answer here. Right, so as you can see here, the answer was specified here. So you can see that the site is working pretty fine, and the we have also gotten to know about the models, views, template architectural system, how exactly Django helps us in handling the front end, handling the database management, and also working with the back end for a website. Right, so this is that, and with this we have also completed the second part of the project, that was building our website using the Django framework. Now, just before uh, moving forward to the third part, what I want to specify is that you will have to create a requirement.txt file whenever you want your, actually this is a very good practice to create your requirements.txt file for any project or for each and every project that you have, because this then specifies what all dependencies and packages did you use and what version of that package did you use. Because sometimes what happens is that people write blogs and stuff about projects, and then you see all the packages they have used, but when you try those out you understand that some of these packages are creating problems for you, because in the versions that the blog people used, that was a previous version where there were some different functions created, and the new versions, the functions created were different, or the functions used were different, so it creates conflict for that, right? So this is a good practice to do. And the other reason why I've created this is because once we SSH into our server, so to set up the server, it also needs to understand all the packages that are being used, and there the requirements.txt file would be very extensively used, right? So I'm going to stop here, and in the next video we would start with the AWS services, getting to know about the cloud server systems, and lastly working on how to push our code into the server and set up the server so that our site is live. Hi guys, so this will be the last part for the project where we're going to host our site using the AWS services. And now once you log in into your account, or if you have to create your account, you just need to uh, click on sign up in the AWS management console. That would be the aws.amazon.console. So there you would be able to sign up, and it would ask you to provide some details and information, and after that you have set up. It would take some time, but then it would create your ID and provide you the message on your email that your ID has been created. You can just log into it and start working with the AWS services. So this is the dashboard that you're going to see after you log in, and uh, this is the area that I'm using the servers of, right? So you can just change that to any nearby location that you have. So it would be using those servers. And yeah, so moving forward, some of the first services that we're going to use would be the EC2 service, right? Even you can see here that I have recently visited to the EC2 and the S3 services. But for this project, we're just going to use EC2 only. And right, so when we talk about EC2, the actual name is actually Amazon Elastic Compute Cloud Services, which provides like scalable computing capacity in the AWS cloud, right? And using EC2, we eliminate the need to invest in actual hardware, which is like pretty obvious, right? Why we are using EC2 instances, or even for that matter, why we are using AWS services, right? But uh, EC2 has some of the following features which I would like to highlight because there are many reasons why EC2 is used by a lot of people, and some of the reasons I'm going to specify why I've used this for this particular project. Okay. Now, we have pre-configured templates in our instances, which is also known as Amazon Machine Images, AMIs, right? That package the bits you need for your servers. And when I say talk about package, that means including the operating systems and additional softwares that one might require in your server, right? Now, the other thing is that EC2 has unlimited categories of servers that they can provide you. They have various configurations of CPU, memory, storage, and even networking capacity for your instances, right? So that is one more reason why people go for EC2s. Then we have the secure login information for your instance using key pairs. Again, I would talk about this in a bit, right? And now the storage volumes, yeah, so this is important. So the storage volumes, when we talk about storage volumes inside the EC2 instance, right, in the server, so they are for temporary data. That means that once you stop your service, that is, once you stop your instance, all that data will be deleted, and you would need to again, right, you would need to again maybe load that data from somewhere or create that data, right? So that is also something to note about, because if you have important data which was created on the server, then you would maybe think twice before clicking on stop button, right? Then the servers also have a firewall that enables you to specify protocols, ports, and even source IP ranges that can reach your instance. And when we talk about reach, we mean that these IP addresses can connect with your server. Right. So, okay, so let's just start with the hosting process. And here, if you, okay, not from here, it's better to go in the search bar and search for EC2. You can see that there are services present here. Then there are features also. But we would be, since we are creating using a service, then first we would just go into this service. And okay, this is taking time. Yeah, so okay, so you can see I have created some instances, right? And then you can see some of the buttons here. So what you have to do is you have to click on launch instance. So once you click on launch instance, it asks you as the first step to choose an AMI, that is again Amazon machine images. Then you can see here there is an Amazon Linux server provided to you, and it is free tier. Then you again have an Amazon Linux 2 AMI. Now it also provides you with the description of what this AMI includes with itself, right? Then there are two type of architectures that are provided by Amazon. 64-bit for 86 and 64-bit for ARM architecture. Then you have Mac 2, Mac OS, and those are of three type. You can even see that these have different capabilities, but you can see that these are not free tier ones, right? Then if you want to create your server that is going to host databases or is going to be used as a database application, then you might want to go with the Red Hat or the COS Linux. And then you can even use Ubuntu or Microsoft, but for other things also you can use Ubuntu or Microsoft, right? The Windows OS. So we would be going forward with the Ubuntu server. You can take any of the above ones or the below ones, right? So just click on select here. Then it would ask you to choose the type of instance. Now you can see the free tier, right? I'm going to use the free tier ones. And you can even scroll down and see how many types are present, right? And even if you go and have a look, you can see that the number of virtual CPUs, the number of the RAM, the data storage capacity, the network capacity, all of it, these are different for different types, right? So I'm just going to use the T2 micro one, and you can see that the network performance is low to moderate. And again, this is what we require because neither is our site very heavy, neither we would be getting like 10,000, 20,000 users on our site at an instance, right? So from here, what you can do is just review and launch. But if you want to uh, configure your instance, you can move to the next part, that is configure instance details, which again provides you with a lot of specific things that you can do with your server to set that up. The first thing is number of instances. If you don't want to use just one, you want two, three, so you can just input that here. Then three instances will be created, and you can use those three instances simultaneously. Next, you have the network group. You can create a network group or you can use the default one. Then the subset preferences. You can see no preferences is being specified here, right? But you can use some of the subnets that have already been created by me, right? So if you're just creating your first instance, it would most probably be empty. But because these three are actually subnets that were created by the previous instances, right? Then there are some other options that you can even go forward with. Here you can even see there's a shutdown behavior. That means that when you want to shut down, right, when you want to actually shut down your instance, you might need to click on stop. But if you choose terminate here, then unless you click on terminate, your instance won't stop or your instance won't shut down, right? Then the next is to add storage. If you want to add storage, so by default or by in free tier, we have 8 GB of storage capacity inside my server instance, but you can increase that. But notice that when you increase and launch, it would ask you that there's going to be a fee for that. This is not for free. If you increase your size capacity, if you change some of the default configuration, it might add on to like uh, it might add on to the fee you might have to pay later on. But here you can see that the free tier eligible customers can get up to 30 GB of EBS, right? That is elastic beanstalk storage. And then we have the general purpose SSD. So we have the general purpose SSD. So you can increase that to 30, but after that, it would start charging you. Then next is add and configure security groups. Again, we would come on to this later, so it would be better to not configure your security groups from here or from this panel, right? So you can just click on review and launch. Once you click on review and launch, it would ask, the pop-up would open and it would ask you if you want to use an existing key pair or if you want to create a new one. So click on new one, right? Let me just click on this. Right, so this is going to just give you an brief of what you were. So here, see, it would ask you to choose an existing key pair or create a new pair. So just don't ever go with proceed without a key pair, right? This is very important. So create a new pair. You can have both of these, but I prefer the RSA one. Then just name your key pair, whatever you want to name, and just click on download key pair and save it at a place where you can access it. So I won't be doing this because I've already set up instance for my predicting for my next word or next sequence prediction model. Okay, but you have to keep that key pair safely somewhere because we would be using that. And if we don't have the key pair, we won't be able to connect to our instance from our local machine. Right, so this is that. And so I created the, yeah, okay. Delete. Right, so here you can see that so this is not exactly for the predicting words, right? But you can see that the instance, when you click on the instance, it gives you an instance ID. It talks about public IP4 address. It talks about uh, private IPv4 addresses, your DNS name, your private DNS name, right? And gives you information about the instance type, the AMI you are using, the AMI ID, and so on. Then you can even go to security. Here it would talk about the security group that you're using and the inbound rules and outbound rules. So before we move forward and check all of these, let me just give you a detail about some of the terms that would be required by you to understand so that setting up the AWS instance is a pretty smooth process for you. So the first thing is the public DNS. Right. DNS is domain name system. That is a standard by which names are used on the internet and are resolved to their corresponding IP addresses. So when we go on like www.gmail.com, let's say, right? So when you go on that, it actually what this does is that the server sees that yeah, you have gone to this URL and this URL is mapped to this IP address. So I have to reach out to the this server having this IP address, and from there I will say that yeah, give me the front end pages so that I can provide that to my user who has just now tapped into the URL. So this is why DNS is important, right? Now, when you instantiate your instance, AWS provides you with a public and a private IV4 address, right? So public IV4 address is able to communicate over the internet, while private IV4 addresses is able to communicate with the network of the instances, which basically means that you need the private one to connect with other instances. You need the public one so that you are able to connect to instances all over the internet. Okay, so that is that. Now we talk about inbound and outbound rules, right? So a security group, which can be seen here, right? The security group and something with launch wizard 7 is here. So security group actually acts as a virtual firewall for your EC2 instance to control the incoming and outgoing traffic. Like when we talk about traffic, we just mean connections. Who is able to connect to your instance, who is not able to connect to your instance, is your instance able to connect to other people or not? That is what I mean by incoming and outgoing traffic. Now this might maybe not have cleared what in what the security group does exactly, or what these inbound rules or outbound rules are. So basically, inbound means incoming connections coming to your EC2 instance, where the situation is like you are trying to, or somebody is trying to connect to your instance. So if somebody wants to connect to your instance, then inbound rules have to be set up, which means that on port 22, anybody who's on port 22 would be able to connect to your instance if he has the key pair, right? The password. Then on 8000, anybody who wants to connect to your instance will be able to connect, right? The source means that anybody, basically anybody would be able to connect on 22. If I had a particular IP address here, then only that particular person on that 22 port would be able to connect to your instance. Then there's the outbound rules. So for outbound rules, it means the outgoing connections from your EC to instance, like which basically means that to connect to the internet or any browser, you have to add an outbound rule so that your instance is able to connect with any instance that has been, running and is connected to the internet. So that is why we can see that our instance can connect on all ports and the destination is all, which basically means the source is all, right? So this was about the security. Now, Amazon also provides you with a virtual private cloud, also known as VPC. You might see that here. You can see that there's a VPC ID and there's even ID. Okay, so that is just ID. You can just click that. There's a subnet ID also, and it also provides you with the availability zone, right? Now, VPC enables you to launch your Amazon Web Services and its resources into a virtual network that or or the Amazon has automatically defined for you. Now, this virtual network resembles a traditional network that you would operate in your own data center. But the benefit of this is that it is a scalable infrastructure of AWS. So each VPC defines what your AWS resources need, including IP addresses and subnets. So all of the IP addresses that were defined here and the DNS and the subnets that are defined here is actually instantiated by your VPC. So at a high level, you can think of a VPC as an logical container that separates resources for you to create, right? Basically, okay, so basically what you can think of it as that a VPC is like a apartment where your furniture and items are analogous to databases and instances that you're using, right? So it creates compartment and uh, sets those instances and databases uh, at particular places and says that yeah, I need these resources here. So maybe in room 2 you would need to send this, and in room 1 you would need to send this, right? So this is how VPC is working. So this was a lot of technical terms, right? So moving, okay, so in the next part we would move on to the actual uh, actual setting up your server, right? We would SSH into the server, and from there we would take on setting up the server and finally running our. Yeah, hi guys. So in this this most probably will be the last video, and we are going to work with some of these softwares that you might need to download, right? Because setting up the server can be made a lot easier with these softwares. So the first software that I'm talking about is the Putty software, right? Just search Putty and you can see that there is a download link for that. Just go on this link and download the Putty software. Now you can see that this is a free SSH and Telnet client for Windows. Then the next is Putty Gen. So you can just download Putty Gen for here from this link, right? And the last uh, software is the WinSCP. Yeah, sorry, WinSCP, right? Not, yeah. So you can just download from this link here. Okay, so once all of these are installed, right, downloaded and installed, we would be using these softwares to first connect to our server using SSH, and then we would even send our files from a local machine to our server, And lastly, we would set up our server so that we can run our Django project inside that server and host it on the same server, right? So for that, right. Now, as I told you, once you launch your instance, it asks you about a key pair, right? So you must have saved that file somewhere. Well, I hope you must have saved that file because that file is like a password which AWS commands whenever you're trying to connect to your server from your local machine. Okay, so just first go to your just open the Puttygen. You can see, right? So just open this software, right? So it gives you an option of generating a public private key pair or loading an existing private key file. Now you have to actually load because you already have the private key file, and wherever you have saved that file, right? Wherever you have saved that file, just go there. I think it is saved here only. Yeah. So your file would be saved as a .pem file, and when you load that in your Puttygen, it only looks for PPK files. So you have to go to all files to see to actually look at the file. So just click on this and click on open. Once you click on open, uh, yeah. So the next thing is to save the public key or save the private key, right? So we would click on save the public key, and this public key is what is acting as a password for your instance. Okay, now you can see here type of key to generate. We have RSA, we have SSH1, that is also for RSA only, and then there are some other uh, encoded parameters, right? Encoding parameters. So just click on save public key and save it in somewhere that again you can access. I've already done that, and that is pretty much evident from here. You can see that a PPK file is present here, right? So just name it whatever you want and save it someplace where you can access this, right? Now, once you have uh, created your public key through the Puttygen, go to Putty and open the Putty software. So it would ask for your host name, right? Now for host name, you can take that from the details that AWS itself shows for the uh, instance that you have selected, right? So just click on the DNS and click on here and just go to SSH authentication, and here it would ask you to fill in the private key for authentication. So you just have to click on browse, then you would need to browse to that particular page where your private key file is present, the ppk file, right? So just click on this, click on open, and then click on open. Now it would ask you to log in as, right? And now since I'm using the Ubuntu AMI, you can see that the platform is Ubuntu, and okay, it is not showing here right now like it used to. But basically, when you have used Ubuntu, then your username is also Ubuntu, or you can create other users as required. And now it also gives you a specific information about your system, that there are 100 processes running currently, the IPv4 addresses, the memory usage is 20%, the usage of disk is 18.5%, that is of 7.69 GB, right? So that is that. And yeah, now there are some particular commands to run, but before we actually set up our server, we need the files that we have created for the Django to be here, right? So for that, you would use the third application or the software, that is WinSCP. So just click open, and it is again going to ask you for the domain. Okay, yeah, here you can see, just click on new site because I was working with it previously. So it would again ask for your host name. Then it would ask about your port number here, right? The port number here, and that is 22. Again, if we want to connect to the server, we need to connect on this port, and the host name was, I think, still copied. Yeah, the username is Ubuntu, and lastly the password. When we talk about password, again we go into advanced, and in advanced we go to the authentication. Then we browse the PPK file we created. Yeah, the PPK file we created. Yeah, open. Okay, and login. So it would ask you if you really want to do this and the details about it. Then yeah, so you are now inside your server, and you can see that there are no files present here in the Ubuntu directory, right? Now, on the left side, you have your local machine. On the right side, you have your server. So just go to the folder where you have saved your site, website files. Right. So this is the website file I have. Okay. So just go back. Now you just have to drag and drop here. Click on OK, and you can see all the files are now getting uh, transferred from your local machine to your Ubuntu server. Now I'm just going to delete this file here because this is not needed, and if somebody is able to access that, then oops, he's going to get the access to your server and can just do anything about it. Okay, so yeah, now you have your files in your directory, sorry, files in the Ubuntu directory also. If you just run the command this, you can see that we have our my site directory here, right? Now there's some commands that you can also run in the uh, AWS server so that it makes things a little easier for you later down the line. The first command you should know about is the sudo command, right? So sudo is like basically you run sudo with other commands, right? You run sudo with other commands that you might want to run, and the sudo part gives you the administrative rights, right? So even files that you can't access as a user, with the sudo command you would be able to access those files or even make changes in those files. Then the next is the pwd command to give you the directory and the path you are on right now. Then as I used ls-a, dash a is a flag which asks you to provide a list of all the files and folders present inside the current directory we are in. Then we have the nano command, and let me just show you. Before that, there is also a cd command which is quite known, right? Uh, yeah, so let's say I have to make some changes in my requirement.txt file or any file for that matter, right? So you use the command nano requirements.txt. So here you can see that the file has opened in the default editor, and you can just make changes in your file. Once you make changes in your file, you can just Control X, and then it would ask you to save. If you want to save the changes, you can just say bye, and then it would ask you if you want to keep the name the same or you want to change the name. That is on you. And lastly, it would save those changes, right? So this is the nano. command which helps you in opening the editor and making changes in your files. So next is the mkdir command, which is to make directory. If I want to make a directory inside this my site directory, then if I just type in here, you can see that the directory one also was created here, right? So let's say if you want to remove a directory, that is rmdir, yeah, rmdir, then the name of the directory. So you can just remove that, right? Then the next thing is if you want to find uh, if you want to find some files, there's a function for find, and then the name of the file, right? It would be finding the file and also giving you where the file is right now. Then there's a command that is df-h. Again, h is the flag. You can see that for the root system, which has a size of 7.7 G, that is gigabytes, we have used 1.5 GB right now. We have available this much. Then for other folders that have some specific, sorry, other folders, not, but other disk spaces that we have specified in this Ubuntu, we can see how much of it has been used and how much is available. Okay, so these are actually for snapshots if you want to create a backups. So that is that. Right, and then yeah, we can I think move forward with running the actual command that is going to save that is going to help us in running the server. Now, what I have done is that I have just created a file for all the yeah, I just created a file for uh, for yeah, I've just created a file, and in that file I have specified all those functions that I would require to run to set up my server. So if I just right click here, so this command which you can even see here is to install your pip3 so that later down the line you can install all your packages. So if you click on that, it is going to start installing your pip3 and integrate it with your Python version that has been already installed on the server, which I'm going to show you in a minute, right? So it asks for a yes or no between if you want to continue, and you have to continue, right? So this is yeah, so it has finally installed, right? So if I type in Python 3 dash dash version, you can see that there's already a 3.8.10 version Python installed in Ubuntu. Okay, then the next thing to do is you can see that we are already inside the my site directory. So the next thing to do is actually pip3 install dash r requirements dot txt, right? So it is going to install all the dependencies that we have and the packages we need for Django project to work properly. So again, this is going to take some time, and now you can even suppress the warning by using the dash dash no warn script location. And this is actually happening because we haven't created a virtual environment on the server, which is actually a good practice. But unless you are working on this project and will be working on this project, creating, updating things, only then I would require you to create a virtual environment and then start all of the processes that we did. Now you can just run python 3 manage.py run server. Okay, not run server, sorry, migrate. Yeah, so I got that error because I haven't specified the .env inside my requirement.txt. I just got just fixed that up. So I had to keep the python.env and the version inside the requirement.txt, and I just installed that also. So we can just run the last command again, and this time it won't create any problems, and you can see that it has seen the migrations it needs to, and there are no running migrations to apply right now. And the reason for that is because we have just directly loaded our model, sorry, the code from my from the local machine to my server. So even the migration files have been loaded, right? Then the last command is just to run server, but on all and the specific port. So if I run this command, it would just check and then say that, yeah, you can just run right now. And when I say run, I mean you can just run your URL, and so this is to take some time. Now, as you can see, it is not working right now, and that is because we have missed a very important thing. So as I was talking about inbound rules, you can see here that we don't have the inbound rule for Django. That means that my Django, which listens on 8000 port, is not specified here. So that is why, even though everything is correct and we are trying to access the URL, we were not able to go. Now what you have to do is just click on the the security group rules, and then here click on edit inbound rules. Here what you have to do is add, so that would be custom TCP with the port 8000. Then anybody can connect to that and just save rules. So click on that. Now in your inbound rules, there's an SSH port for the connection, and then there's for the Django one. Right, just go back to your instance. Then inside your instance, just refresh this once. And once you refresh, you would be able to see that the new inbound rule that we added now is shown in the list of inbound rules for this particular instance. Right. So yeah, it would ask you. So just select one instance. Okay, right. So just select one instance, and then it would give you the details for it. And inside your security, you would be able to see the rules specified here, right? So if you just go to the site again, if you click on that, you can see that now you have your site online. And just again click, um, just to check, right? Just to check, you just click on submit, and yeah, so here you can see that we are getting our results here. So with this, we have also completed the last part, that was uploading and hosting the website on AWS.